you're up.
Hi everyone, welcome to LiveCon. Thank you for attending the Dante class. For those of you first time, welcome. Second time, or third time, or fourth time, welcome back. Today, Dante class is going to be presented by Jason. He works at CLQ. He's a great, great partner of ours. His classes are awesome. I've sat through many of them. So
Building this up a lot.
Soak it up.
You're
Soak
building
it
this
up.
up a lot.
Yeah.
Jeez. I know, right? No pressure now. Thanks, Dawn.
Right, so further ado, Jason.
Thank you, Dawn.
You're welcome.
I want you to continue to clap, please. Not for me, but for the text, right? Okay, usually I'm on that side. Today is super cool. I feel like a rock star. I walk in, they're like, here's your mic, sir. Here's your video presentation. So that's super nice for me, for a change, to be able to do. I did take a picture of everybody because now I don't have to write a trip report. So if you need to sign a waiver, feel free. Oh, take me off of there, please. Okay, there we go. So, first time? Anybody? Everybody? Second time. Have you sat through one of my presentations before? Dawn is the only one. Okay. Remember Dawn. She's a glutton for punishment. So here we go. Is anybody familiar with Dante? A lot? A little? Some? I know you are. Does everybody know Mark? He's one of the lead designers here. He's extremely familiar with Dante. He's here to not only heckle me, but make sure I don't say anything extremely stupid, which is going to happen no matter what. So you're familiar, I know, a little bit. Have you implemented any systems? Okay, so you got a handle on some things. So what we're going to do today is pretty high level and just kind of reviewing. Thanks for lighting the stage up because I would have crashed otherwise. So what we're going to do is what, why, where, when, and how, what Dante is, and to kind of explain that. And Dante is spoken here. You'll see that logo a lot because that's kind of the key factor that we're looking to get into and do. It's hard without my monitor to remember where I am. What? It's a digital audio networking protocol. Okay, so it's when we want to take, I forgot I have this. If we want to take all these sources and throw them into this mixer, and now we build a network. Everyone's familiar with their computer network, right? Anybody in here an IT person? Okay, I am not. So if I say things that are horribly off track, just heckle me or just let it roll, okay? Because I'm not that guy. I'm an old audio dork, and I've been forced in the last decade to start putting my audio on a network because it only makes sense, right? So you're going to understand the networking portion. Do you guys comfortable with audio also? A little bit? Okay. That's where I like to be. Mark can do both. I'm sure a few of the other guys can do both. Mark's the one who's taught me to, be quiet a lot. But you can see it's audio meets IT. And that's what kind of the secret we're talking about here. Keep pressing the laser button. Sorry, I'm going to blind somebody. It all starts with sharing, right? It's all collaboration. The collaboration and innovation, that's the topics of today, I believe, the theme for the live con this year. So let's go on a little history lesson because everybody likes to come to classes and go to school. So let's talk about speech. That's pretty simple, right? But this guy wanted to share, so now he's starting to develop the first public address system, right? This guy says, let's make microphones, but now we've got to put them into something. So here's one of the first sound system PAs. We've made a few advances, and that's actually Woodstock photo, and you can see how tiny. I'm sorry, every time I turn, you're losing me, huh? So I'll present like this the rest of the time. There's a PA somewhere in this mass of people at Woodstock. And you know where we're at now with things. We have column arrays. We have full concert systems that can knock you out of the water. So if we take the history of writing now, it became very simple. Now we're going to have a written language. Then this poor dude, oh, wrong button again. Give me technology, I'll screw it up. This poor dude sat and copied things, right? The monk copying things over and over. This guy says, nah, man, watch this. He now uses the technology to push and innovate. Now we get into making newspapers. Well, you guys would like to read a newspaper, but what about these people? So now we have the Pony Express, and so on and so on. This is actually a shot of a post office. Are those graphics coming out all right out there? Not awful? I think that's the day the letters from Santa got delivered. But that was, now we have the post office, right? So as We need to communicate more, either verbally or in writing. We are using the technology to push forward our advancements of sharing, right? So more collaboration. So this dude's name is Monk also, so I thought it was kind of cool to throw him in there. If I want to listen to Monk, I have to figure out where they're touring, and I got to go there and see them live, and I'm done. We all know who this is. Anybody? That's Edison, right? Yeah, that's the cylindrical photograph made of wax cylinder that he recorded the voice, right? There's a photograph. Everybody, there's a lot of youngsters in the room, which is fantastic. You guys go wiki, wiki, wiki with all the albums now, right? It's actually vinyl's a new trend, back a new trend, maybe not. Reel to reel, who's had those? A couple folks, right? Into that fabulous 8-track? Yeah, okay. Cassette? So there's evolutions, right? Getting better, maybe, I don't know. So we've moved forward. So in speech, we want it to be faster. We want more information. We need it to be faster. So we developed this telephone. Who did that? Bell, right? Bell Laboratories had a humongous influence on the audio industry. The decibel, that is part of Bell. It's 1/10 of a bell, which is 1/10 of a factory, I think. I'm not sure. What's that? Switchboard? Old switchboard. Now, as this traffic continues, as more happens, it needs to be run and needs to be faster. So now somebody has to manage that traffic. And same with the writing. Does anybody know what that is? Any youngsters know what that is? Yeah, right on. Okay, so they're still teaching stuff. That's cool. That is a telegraph, Morse code. Beep, 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 beep. Does anybody know which one I just did? SOS, because you're all going, God, this guy's killing us already. SOS, get me out of here. So that was, in my mind, maybe an early form of what we're going to talk about. What's this one? What's she so happy to be doing? On a telephone line, sending a piece of paper. Anybody still use a fax machine? Yeah, so do I. Okay. But there's, again, technology. It's more information. It's faster information. So here's the quick evolution of communication I found. I thought was kind of neat. So here's cave paintings right on that edge. Mark knows I'm going over the edge. Pigeons, guy running. That's kind of the predecessor of the Pony Express. So here's Common Era. I don't know when that starts. You know, here between 500 BC and 1816. Here's that newspaper. Here's a phone, telegraph, radio, right? Radio goes and forms itself into visual radio, which is television. A lot of the stuff, look at the timeline though. Most of our modern technology or variants of that modern technology are only about 100 years old, or a little over now. So commonality of all this is it's all analog. It's some sort of analog wave, right? Nothing's really changed until right around here. That was when I was born, by the way. I invented the internet, me and Al Gore. We sat around, I was like this big. What was the change? What happened? That happened. That was the computer we used to invent the internet in 1969. That's what happened. Watch what happens next. Technology explodes, right? This, oh darn it, wrong buttons, always wrong buttons. This is the original computer punch card, right? It morphs into the matrix all of a sudden by use of all this binary. Does anybody understand binary language? Can you just rifle off and start writing it down and switch it over to hex and ASCII? I can't. No, you can. No, you got a chart too. I know you do. But this is all of pretty much our computer keyboard symbols are in this chart. And it's all ones and zeros, right? Simple. Beep, 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 beep. Sounds like Morse code to me, maybe. So maybe that's what I mentioned earlier. Did this kind of, somebody turned on a light and said, we have to simplify this to zeros and ones and now make a very simple string flying down. There's a byte, right? Everybody knows a byte and kilobytes and whatnots. There's a bit, 1/8 of a byte. So that's a lot of information coming at us fast, right? But we need more and more and more and more all the time. We're humans. We have to have more. We have to have it right away. So remember sitting around listening to the radio, gathered in the family room and listening to the flash? No? Okay. Black and white TV? Who had black and white TVs originally? Who's never seen a black and white television? Looking at you guys. Have you? I'm sorry. I don't mean to do that, but there's the technology. I remember when it switched and transitioned. Luckily, since I was born in that 69 era, I've seen a lot of this technology roll really fast and exponentially, and it's kind of terrifying to me because I'm having a hard time with this thing. Now we have giant home theaters, right? With HD and 4K and 3D and all the fun new technologies. What about that guy? Remember those? Anybody have that one? Yeah, sure. Blackberries? I had one, and I still have one in my desk drawer. I don't know what we're going to do with that. And now this guy says you have to buy a new one with no headphone jack. Does that matter? Do you care? They have the little wireless ones now, right? It's not far off from that chip right here in the back. Plug you right in. So this is currently what happens, right? On a day-to-day basis. This is what we asked for. We wanted more, and we wanted it faster. Here's your bytes. Kilobyte, megabyte, gigabyte, terabyte, peta. Anybody have one of those drives yet? It's coming. Yettabyte? I want a yettabyte. How many bits is this? That's incomprehensible. There was no billion in my head when I was a little kid. I didn't even understand what a million was. And now we're talking about zeta and yettas, and it's a mythological creature on a mountain, isn't it? The Yeti? So here's all your cable channels you would ever want. All these things. I'm not predicting the future. I'm just saying. So that's about Dante. Ta-da. I just wanted to kind of show and explain how this all kind of came around and got to this point. So let's really get back on topic. What it is, why, when, where, and how. For me, innovation. All right, collaboration, we talked about sharing. That was a theme for the day. See, I hit the themes today? Mm-hmm. Innovation. That's what we're really talking about. We are at the coolest point in time. For me, this is so exciting because we can, what do you want to do? I want to do everything. You kind of almost can. It costs a lot of money, and it's going to take some time and real intelligence and engineering to put it together, but you can really do a lot of that. Where it really shifted and changed for me was with the compact disc. For me, and being a musician and loving music so much, when I didn't have to worry about making a mixtape anymore, and there was this thing, the first demo I had, the guy threw it across the store and bounced it off the wall, and then he put it in the CD player and it worked. And I went, what is this thing? And it was clean and it was clear. It was kind of cool, right? So why we do this is it's better, is it? I don't know. You have the debate. I like analog. I like digital. Either way, it's lossless. Once you build it, it's now ones and zeros. Unless something falls off of that string, you don't lose generations. So you remember making cassette tapes and burning one for your buddy, and he burned one for his buddy, and by the time that he handed it to his girlfriend, she's like, "You like me that much, huh? This is gross," right? Dating myself, you guys don't understand. You got the mixed CD. You guys don't even use physical media anymore, do you? Really? Very little. I mean, that's cool. Most people. I don't mean to single you younger generation out, but you're the ones that are teaching us. You don't need a disc, old man. And I realize that, but they're all like $1 now because no one wants them anymore. It's interference free. So once I put that on that cable, this digital string flies around. It doesn't pick up radio interference. Anybody ever have the microphone cable coiled up and it's picking up a radio station, right? We don't have those issues with digital. Distance, we can push these things forever. We put it on fiber, it's off and running. And retrofitting makes things really nice. So now that we've done history, we're ready for science. Everybody's going SOS, dee 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 dee. It's very simple. We take an analog signal, we run it through this ADC thing, analog digital converter, and we make digital. Just like this. That's how we do it. It's amount of information over time. I'm going to go quick because I can tell you guys don't like science. My job is to try to show you a little science without everybody going, no. So sample rate is how many. That's all we're looking at. If we look at this as a grid, so up here we have a grid, and down here we have a grid. It's the same information, it's just a resolution. Everybody wants the highest resolution, right? So we have sample rate, which is how many times a second we're taking a sample. And you can see here's a low sample rate. We're taking that 4 times in a half a cycle, and then many, many more times. Here's 8-bit, 16-bit, and 24. And even the resolution on this screen, you can see how much cleaner it gets, right? Can you guys see that one? Yeah? So there's one thing. Now we look at bit depth, which is now the amplitude or vertical of that. So how many are we pushing in here versus how high we can stack that up. And the same thing happens. Here's two bits, here's 8. We can track that original wave closer. That's the goal. Here's an analog wave. How do we track that with cubes is really what we're doing. We're going to stack blocks up, kind of like a weird Tetris version, and we're going to build as close as we can track that wave. So you can see there's resolution, 1-bit, 4-bit, 8-bit. And now we're at 4K, and the 8K is coming, and they're already threatening 16K, so hold on. I know, right? What are we going to do with that? Here's just a real quick thing now to think about. So we're tracking this wave. We can do it. It's easy. We can do it right now. We can track it out to 192,000 samples a second. Anybody count to 192 in a second? Because I can't. The computer made that possible, right? We're doing bit resolution height at 24. We can do 32-bit. So we can do resolutions that are huge. Here's the issue. That's a lot of information, right? So what's happening? What do we call that? What are we chewing up? Right? There's the key. This is the key to all. How much of this information can we jam down the pipe? We can capture it. We can move it. We can do it. But now, IT guys in the room, you're going, how much bandwidth do you cats need, right? You're going to get on our network and you're going to chew up our bandwidth, and we need it for everything else. Email, surfing, streaming, et cetera, right? Guess what time it is? Time to talk to you cats. Anybody ever do an Ookla speed thing on your computer? Pretty simple. You just go click and it goes, hey, here's your speed. It's up and down. These are the things that we have to consider now. I don't like doing that. I'm an audio guy. I know how to do some of this very rudimentary, and then I call my friends. If you don't have an IT friend, find one. I'm not kidding. It's true. There's one right there, and apparently these 2 cats here will do it too. But we can jam almost everything on the internet, including video. No problem. We do YouTube. We stream on that. You can do all these things, but somewhere somebody's pushing bandwidth all over, right? Yeah, I know. This is Dante, right? And I'm already halfway done and haven't even really talked about it. There's a reason why it's almost so simple that I'm going, I can't talk for more than 15 minutes on Dante. I can, but then we'll get real techie, and everybody who didn't like science is going to go, shut up. They probably are. That guy back there is already thinking the same thing. So let's do a real quick history review, because everybody liked the history portion, right? No? Okay. We've had in the past the ability to move audio on a digital network. Kind of big time started in CobraNet. Anybody use CobraNet? Okay. It wasn't the most fun thing to do. There was a lot of IT-based criteria that we had no idea what we were doing. Okay. There's other ones in that proprietary column. There's companies that have their own. The Harman Group has a networking topology. I work for Bosch Group. We have ours. They're all a little bit different, but they're all doing the same thing. Anybody heard of AVB? Big buzzword for the last few years, right? AVB is awesome. It's cool. It's great. A is audio, V is video, and B is bridging. So we're bridging to streaming. That's all it really is how do we stream this? Dante is the A. There's a firmware change and a couple other things, but for the most part, the company Audinate worked, that's who invented Dante, sorry. They worked with the guys at AVB. The cool thing about the Audinate guys is instead of a bunch of us audio guys that can't even turn our computers on half the time, this is the guys that are IT guys already. And they use, I don't know, standards on how the Ethernet works. They're using protocols. that are tried and true based on internet, IEEE, fancy letters and numbers that work. It's a standardized thing, and that's where we had never had anything in audio. There was just, hey, we made this, and we're going to throw it on this network. Does it talk to ours? No way, man. What does it talk to? It talks to ours. You got to buy all of ours. Well, as you know and we know, nobody wants to be pigeonholed into some solution, okay? I represent about 24 brands total. 6 of them play on Dante. One of them plays on CobraNet. But if I need to intermix those now, and that's only a few brands. So now if I need this speaker and this amplifier and this piece here, I want to try to have some commonality. That's where the Dante guys are winning the game, okay? By a lot, okay? This is where and why, or no, when, sorry, where and when. Right now, it's happening. This was an independent study I saw at Infocom, the big dork trade show we go to every summer, and an independent consultant from Britain has been studying digital audio networking because he was curious on what he was going to start to recommend to his customers. And he's been tracking this. This is only a couple years worth, but there's AVB. AVB was a huge buzz, and it's losing traction because they really had a hard time catching the V part of it. Audio bandwidth's big. Video bandwidth is humongous, okay? And now when you're talking about, with the evolution they're having from now to 4K and 3D and all these new factors the technology driving video is coming up to, they've kind of went, okay, where do we jump back in? So that slowed down momentum. CobraNet, you'll see is falling off. You're welcome. It's not that bad, really, but it's just so much easier. EtherSound was a proprietary, and Ravenna broadcast guys, anybody? Ravenna's a broadcast standard. So you can see Dante's exploding. It's literally exponentially growing in the last 3 years. I first heard about it probably 8 years ago at the trade show. My buddy said, have you heard of this? No, come on, come on. And I sat down and I went, that's going to be revolutionary. He goes, yeah, it really is. And there's some reasons why. We have, right now, as of the last trade show, oh, somebody put animation in here, sorry. Over 300 manufacturers in the audio industry are Dante spoken here, Dante-enabled products. That means you can plug it in and plug it into somebody else with Dante, and they will now throw audio back and forth. There's over 1,000 products today that you can start to share. Oh, sorry, installations. Sorry, I'm very sorry. I didn't, yeah. This is actually, I'll have to go back 18 times to get there, sorry. But yeah, that last slide was showing installations across the globe as far as this guy could track. So it's literally exponentially growing, implementing it in the field. So there's tons of options. I remember 4 years ago at the trade show, there was like 5 or 6 guys with this little Dante spoken here. And the last time I went, it just was rising. There was 100 and some, then 200 and some, and now it's over 300 and some. Everybody's doing it. That's why you should do it, because everybody's doing it, right? So I promised we'd talk about Dante. I know I'm going fast, and I'm saying a bunch of things that might not be totally relevant to Dante, but I want to make sure you see some of where it came from and why, and where we're headed with it and what it can do. So we'll talk about Dante now. So on this side, this is what we're doing. Here's our analog. We convert that with an ADC, analog to digital conversion. We throw it over here. Anybody know what that is? I know a couple guys do. Ever seen this model? Understand your 7-layer burritos of the internet? Okay, I don't. I got a handle on which ones I need, which are these 3 right here. Okay, here are some scary numbers. To me, who needs 512 channels of audio moved anywhere? Both ways. We can do that. At 196K. What's the CD sample rate? Anybody? It's 44. How many more is that? A whole bunch. Where's that resolution stop? I actually went to a digital audio class at the trade show, and a guy named Pat Brown, who runs Synodcom, super intelligent guy, great course. If you ever see a Synodcom class, jump in it right away. They're not cheap, but they're well worth it. And he said, okay, let's find out where that ceiling of resolution that we really need is. So he started playing 8-bit and 16-bit and 24, and we figured it was right around 16, 24. Most people are like, okay, I get it. And we started going up the sample rates, and we went to 44, then we went to 48, and then we went to 96, and everybody went, maybe, I don't know. So there's that ROI, right, and return of investment. Where do you make that switch? CD is a pretty solid format still. And then that's why if you're burning WAV files into your iStuffs or whatever, you're going to do a compression-free, waveless loss thing. It still works, right? But we can go up to concert standard. The guys here are running 96 minimum, if not 192. It's all bandwidth based, right? And then 32 bits, that's how high we're stacking that. So it's 32 cubes high of resolution and 192 a second this way, right? We can. Don't have to, but you can. If you don't know this model, it's pretty similar to what we looked at in history, and this is why I showed you the history slide. This model to me is similar to the post office. It's how do I send information from here to there? I put a stamp on it, I lick the thing, I send it put it in a box, it disappears. It's the same as my computer, inbox, outbox, gone, see ya. Where's it go? I don't know, hopefully it'll do what I wanted it to. But if I know his email address or if I know his IP address, what have you, it's various things. This is the physical hardware on the first layer. The next layer is device notification, MAC addresses, right? It's going to this piece of gear, so I can route it to that piece. And then if it has an IP address, everybody's familiar with what those are and how much fun those can get to be sometimes. Now I can send it there. So I'm going to send it to Cleveland, and I'm going to send it to this address with this person's name on it. This is basically really simplified. Don't crucify me here, guys. This is a very simplified post office to me. Hey, send it out. There's what you wanted. I'll send it back. There you go. Is that cool? Can I go with that? They're giving me the maybe. Real high level. So now we're going to look at how long does that process all take. So there's a word called latency, and that's all that means. I say go, how long does it take to get there? That's the one thing on the Ookla test does for you, on the speed test. What's it going to get there? How long does it take me to get that information there? That's a thing I'm sure the IT guys use quite a bit. So all this process of converting and reconverting and then sending it through the network, that's your latency. This part here is what Dante is cool at. We can do variable latency. We say, okay, we're going to put in a bunch of switches and a bunch of hops, and we're moving this signal all around. We can just back it up or down to fit and speed along as fast as possible. We want it to be instant. When we're doing live streaming of any audio or video, it needs to go. There it is. If we drop a bit or two, it's too late. It's live. It's gone. It's not going to get a, hey, we missed that. Can you resend that email kind of a thing? It's gone, you know. But we can we can speed the latency up down to 1/4 of a millisecond. Doesn't register in this brain how fast that really can be. I know when my computer's like, we'll send that email. That's never fast enough, so maybe that's 1/4 of a millisecond. We move everything in flows. That's all our new, it used to be packets. It's still a packet, we just call it a flow. We're going to send some flows over there. We're going to send some flows over here. It can be a unicast, so I can send just to you guys. I can send some separate information to you. I can send the same information to you individually, but that's twice as much bandwidth. If I'm sending you the same amount, I'll send it in a multicast. We can set that kind of up in there. Remember her? That's what we do now. It's just a matrix. We connect this microphone to this mixer inputs. We connect this mixer output to this amplifier, and so on as we need to. And this is really it. It's that simple. If you can understand how to press that green arrow, and the nice part is, this thing really helps you do it. Dante is the closest thing to plug and play we've ever seen in audio, and that's why it's fascinating. The first time I got my samples in, build this Dante network, I'm like, oh heavens, it's IT stuff. This is gonna not be a fun afternoon. I plugged in this, I plugged it into that, and it said, okay, let's do this. And that's literally as close as it gets to be. This is why Dante rocks. To me, I was really going, oh God, okay. It's IT standards. That means we can use standard IT gear, right? Cat 5, Cat 6, whatever variation of Cat cable, we all know what they are. We plug it into a standard Ethernet switch and we're off and running. Yes, you can get in and do some cool stuff. You can manage things, you can manage traffic. That's the part of it. Remembering that we want to do some things when we need to, but in reality, we don't have to. It literally says, like I said, what's up? How you doing, Mark? You there? You jumped on the network. How's it going? Are you the boss? No. Who's the boss? Dawn's the boss. She's not online. We plug in boss. Dawn, she's like, hey, Dawn, you're the boss. You're now in charge. It's that intuitive. It's that cool. It's really slick. And you guys probably have something similar in IT world that does that now. We've never seen that. That's why it's exciting, because you can plug it in and go. The first phone call I had for tech support was a guy called me up on Dante. He says, I've got this box, and I need to hook it up to this box. I've never done this. And I went, neither have I. Let's try this. So I cracked open the help menu, and I walked him through it, and he was pushing audio from one to the other within 15 minutes of never seeing it. That's opening his computer, finding it in the software, dragging it over, clicking the thing, click the other box. Hey, we're both here. Audio's moving. It's not always that simple, correct? But that's at its root-based form, it can be. Then we call our IT friends when it's not that simple. But it just automatically discovers. It automatically sets a clock. Now, if you're thinking about anything trying to sync up and clocking, we have to make certain that all this information is on time. So if it sends from here and it's expecting that train to arrive, at this time it has to get there. But we all have to have the clocks. Remember the old movies where they were going to heist up the jewelry out of the bottom of the floor of the casino and okay, synchronize to your watch now. No? Okay. That's the same thing. It automatically sets the clock. If the master clock falls off, it says, you're the clock now. Mark takes off, Dawn, you're the clock. You can tell it, I want this to be the priority clock. From there, now we can go real granular if you want, and we can take some questions offline after, but there's a lot more under the hood than I'm going to even kind of show you today. QoS, quality of service. We talked about this earlier. This is how much we can smash down this pipe, but now we're going to prioritize it, and it makes sense. I want my audio, it's in my mind, it's critical, or our video, or whatever. We can now set up, you're shaking your head, audio's not critical. Depends on what we want, but we set up different levels of priority. I need my audio. A lot of this only happens when we start to converge networks. I can run a dedicated network of Dante, and probably would, because that's just best practice in my mind. Here's my Dante cabling. But if I have a building with existing infrastructure, cabling, and switches, and networking, and my IT guys approve the bandwidth I'm chewing up, and we have a conversation of, here's what I really need, and they go, yeah, we can do that, and we'll give you a reserved amount and a priority, there's levels to do that. So now when we push this as a streaming priority, it's not going to get all glitchy and weird at the other end. Yeah. There are many more, and I had mentioned this already. There are many, many more things that Dante can do. And now we can field some questions after. The coolest resource is actually the Audinate page. Audinate is an Australian company that developed this technology. These are the IT guys using the IT standards. They are introducing this to our professional industry. Where this actually started to see its life cycle start was automotive and commercial. You haven't seen really a lot of that happening yet, but that's who's basically driving this. And we're just catching on going, this works well, we'll use this please. So they're licensing this protocol, it's a hardware chip and some software protocol to the manufacturers, over 300. They put them in their products, and now we were able to just drop them on this network. So we've talked about what it is. It's audio, it's digital, it's a network. Questions on any of that? I know I went fast and high level. We got it, we're moving our audio, we made it digital, we saw how. We're pushing it on an IT network. It is simple. It's not as clickety-go always, but a lot of times you press it in, it literally says, let's do this. Is your question? Right on. So question was, is it actual hardware? Yes, there is. The manufacturers that want to use their microphone or their amplifier or whatever piece of electronics they would have and throw it on the network. So they would buy a chip, and there's a couple different versions of the chip. I think they have 4 now, maybe 5, that have different channels. So if I have a microphone, I don't need to buy the chipset that can do 64 by 64. I'll buy the small one. So they load this chip into their product, and now when you plug in the CAT cable, it's crazy. There might be some guys here today with some of the stuff. There's just a conference microphone that sits on the table. You plug a piece of CAT into it, and it routes. You guys have some probably, yeah. You can see it. We can show it to you guys. It's really cool. Instead of a microphone cable, XLR 3-pin, it's a piece of Cat 5. It's a smart microphone now because it's now online. It's part of the Internet of Things. Everybody know what that is? See that one coming around? That's going to get crazy. Internet of Things is basically smart everything. I saw the first smart refrigerator commercial. It can tell you how many groceries you have. I'm like, I could open the door, right? But there's that level. It's there. We're getting to that point where we can now do that, right? So if we have the piece of hardware and now we're Dante enable, and all this is now a version of breaking up some header and footers. I need this information to leave here and go there. Then it sends the data stream, and then it says thank you very much. There's a lot more to it than that, really, down under. But yeah, maybe it's a protocol with some hardware underneath. You'll have to find a product that's Dante enabled, but it's exponentially growing. It's not hard to do. Anymore, it is almost everywhere. I can get a microphone and a mixer and an amplifier and a processor and speakers. That's all 5 pieces of an audio chain on Dante network. One thing I neglected to mention why that's cool, it is lossless, it is EMF resistant, but what's cool is I can now route this channel, you saw that matrix, anywhere I want on that matrix. I can send it to this mixer or this amp, or both, or this mixer or this amp, or this one, and I can just kind of flush this network out as need be. There are more rules, of course. It's not just let's just go forever, but there are the options of flexibility. So maybe today we're in this hotel ballroom and there's one next door, or then there's one next door. We open this air curtain and now we can share like that. It's amazing. So there's a lot of flexibility built in, which, yes? You can, you're right, yes. So there's a couple things they put out in the last few. You can, once your computer, you can take your PC, and a lot of guys record shows now, and they'll take that Dante string of X amount of channels, 64 typically, and smash it into their PC. They'll put it into their digital workstation. It tracks itself out. Now you've got that, you can push it back out. You can do testing, you can do virtual sound checks, you can do recording and then mix downs. They've got a VIA piece, which now basically turns our PC into a total Dante endpoint. So now here's our microphone. We've now using our PC as a source of audio. There's some cool stuff in VIA. You can actually link it to your internal sound cards and push your Apple iTunes radio thing right out as an output on a Dante string. So, why we would use it? We kind of talked about that. It can be fully redundant. I didn't mention that much, but it's networking. If we just kind of run redundancy on it, it costs more to do that, but if it's mission critical, it's pretty simple to do, right? Whenever we want to move it, it's an option. It's like every other thing we talk about. Reality, it's an option. I can still plug in XLRs, and I can still plug in, all my cables, hardwire, copper all day long. I can move Dante over Cat 5. I can do fiber. Wirelessly, not so much, because it's bidirectional. There's a couple other reasons. But I'm sure it's
why we did that.
Eventually. Am I picking up somebody else? I'm getting stomped on. You're hoping I'm almost done. This is the first portion. So I think actually, yeah, I'm real close to done. So one thing I want to kind of go in conclusion of, and again, this is high level. Hopefully it was enough of a teaser to dig in. the Audinate site has videos. They kind of start off as what is this, and they ramp up really quickly on how to. They've got tutorials. They have, just since the last trade show, they implemented certification. So I went through level 1 and level 2. There's online, you can take level 1 certification, level 2 certification, and then you have to get tested to complete your level 2 certification. We've got a test run going through the northern part of Ohio next month. There's a couple seats open in Cleveland if anybody wants to come there. The next plan is to run through the southern part of Ohio, and we'll definitely let you guys know that for sure. It'd be pretty much a day. You come in, learn about it in depth, going down, have some lunch, learn about the rest of it, level 2. Then they have a testing center set up where you plug in this microphone and you plug it into this box and you route the signals, you use the little matrix, do a couple tricks throughout the class, and then you'll be certified. And it was one of the easiest certifications I've ever done because the protocol is so logical, it just makes sense. And their tagline is, it just works. And it really kind of does. There's a few things you can make it do, but for the most part in the class, the guy just kept saying, just plug it in, and it'll most likely work. And if it doesn't, then you start to enable the IMGP snooping, right? That kind of stuff. You can do all that, but you don't necessarily have to always. Ta-da. How's that? Was that okay? Decent amount? I know there's probably a bunch of questions, but I'm also backing up against lunch. I've never done a presentation before lunch. Usually it's after lunch, and I got to get everybody back awake and on track. Now everybody's just looking at me going, dude, we're hungry, and there's trucks out. There's a cheese truck. What is a cheese truck? I'm so excited. Is it made of cheese? I don't know. I'm hungry. So any high-level questions anybody wants to review real quick? Go ahead. Sure, it's a network. It's got a computer in it, and yeah, everything can go wrong. The question was, is there any potential problem? Yes, there are. The beauty is it has in that controller, which we just showed you the real quick matrix screen of, the controller has a latency meter in it. It's got a bunch of tools built in going, you can't do this. If you try to click the box, and it'll just say, no, you're not allowed to do this. You have to zoom out and think about it. If it's having issues with, it has detection of what's actually hitting the other end, right? So it says, this isn't getting here cleanly. We need to figure out why and reroute or change to a different flow setup, or we need to maybe look at our latency count. It has diagnostics built right into it. And from there, you get on the phone, and those guys are amazing. Their support team's really on it. It's pretty quick. And the nice thing is they're certifying all the manufacturers. So there's now 300 manufacturers. Somebody in that company is going to know how to troubleshoot it. They're going to know exactly how their gear works. My job mostly is who's doing it, and when something isn't working, who knows how to fix it. And I can do medium level, like try this, look at this, but I know the guys who can fix things way up here. And then worst case, we take it right into that guy. So there's a nice network of people built in. The beauty part is they're used to IT standards, so they have help tickets. Audio guys have never had, hey, this is broken, let's fix it. And they throw it in a pile, and when they get back to that pile, there, we fix this cord or whatever. Now with the IT standards, that we've also learned we need a help ticket in a way to make this roll around. They have help tickets in their shop here, and the efficiency levels just go boom, because you can now prioritize and get things under control. So yes, there are absolute ways to take care of things. So, yes?
What's your feeling on like open source Ethernet cables versus like your own separate like Dante cables?
Oh, so converged network. Right, you can, absolutely. It's all bandwidth. And that's where we start to need to talk to the IT folks. We need X amount of bandwidth to move our audio, please. Always say please. And they'll go, okay, let's talk about this. And then they'll say, yes, you can do this. Typically, we try to push it on its own network, just because then we don't have to worry about anything other than this is what's going on this network. But yeah, you can put it on a converged, I learned that word this summer, converged network, which is all the other data flowing around. Yeah. Sir? There's no bandwidth calculator, and that's one thing I did find out is we have to actually sit and run some pretty decent tests because it's how much resolution do you want in sample rate, how much bit depth. That now puts it in a minimum. So that's the one thing that we've all requested from the AudNate guys is some sort of simple, because the first question out of IT is,